taking shots at the enemy. I'm gonna make it to the top, leave a legacy.
So welcome to my YouTube channel Chip Logic Studio, and in this video we will discuss how to write assertions for APB protocol. So first question should be where we can write assertions. So you can write assertion in a separate module and you can include that module in TB top, or you can write these assertions in your interface. Now I will show you why assertions are important for verification engineer. First I will comment this assertion and I will run a code of APB protocol with its test bench. Our code is working fine and we get our waveforms. This is single read and single write test. 9 is there and we have written the 9. Now we will just uncomment these assertions and I will also show you command line. See, there is nothing except some few warnings. There is nothing error here. Means our test bench is right, but our duty has some problems. I will show you. See, our duty works fine as previously, but see here at 280 nanoseconds and 190, 50. So this much error is present in only one single read and one single write operation we done executed with the help of our test bench, and this much errors are there. So that therefore we used our assertions for writing this. Now we will understand these assertions. First part, which will be your state part. So this is part 1 video of APB Protocol Assertions in SystemVerilog, and in this video we will discuss about how to write assertion of APB protocol. But before that you have to understand the assertion of APB protocol, and I have made separate video for APB protocol verification, and in that I have explained the assertion of APB protocol. So before starting this video you can watch my previous video. So in that video I have explained that AMBA protocol has some states: idle, setup and access transfer state, and in that behavior we are checking with the help of assertions, because behavior can only be checked by assertions, not any other verification method are there other than assertion. So first thing is that this is our FSM state diagram, and this is you can get it your specifications of AMBA protocol APB. And first is idle state, then setup state, then access state, and we will check this state that after idle it is going to set up, and then access state. P select should be 0, and other than that there is nothing should be 1 like P enable or anything. So this will be our idle phase. Second, our setup phase, that P enable should be 0 and P select should be 1. This is our setup phase condition. Third is access phase wait condition, because before P ready this condition comes, and that is P select and P enable are 1, but P ready is not available, then this is wait state, and after P ready is get our signal, our output signal, then we will get our P ready, and our last is access state, and that is access phase last. So this is sequence. In that we have created this our logic of changing our state: idle phase, setup phase, access phase, and so on. Now we have created this sequence. We will write it inside our property block. So at passage of P clock, our test bench P clock, disable if P reset is there. So this P reset is our test bench signal. If there is this P reset signal, then we don't need any assertions, because all the signals will go to 0. If this condition occurs, then we will stop this assertion. Otherwise we will go to our idle phase sequence, that is our not of P select. If it is there, then idle phase or setup phase should be there, either idle or either setup, either idle or our setup. Two conditions are possible. This is our idle phase. So this is our first assertion for idle state. So we have checked our first assertion property. Second, setup state. So first we will see our setup state. Setup space, we have our P select and P enable condition. P select should be 1 and P enable should be 0. And this we will write in our setup phase condition, that if this is true, then at next cycle this is our non-overlapping implication operator. So at next cycle, access phase wait or access phase last should be two possible state, and that should be there. If these things are correct, then there will be no error. This process will be same for all our assertions, that at every passage of clock we will first check that if it is there or not. So our first is idle state is completed, second our setup state is completed. Now our access wait. So access wait condition is that if access phase wait is there, then at next cycle our access phase wait or access phase last, these two possible states are there. If these two states are there, then it is fine. Otherwise the assertion will be error. And at last we will have our access last state, and similar for all the assertions, we will check our first reset, and then we will check our access phase last. If this condition is occurring, we will check that our idle phase is there or setup phase is there. The similar thing we write in our FSM. First idle condition we will check, either we will go to idle or either it will to our setup phase. Setup phase we will say either it will go to access wait or either it will go other to our setup phase. Similar to access, either it will go to idle or it will remain in access phase. So this condition we will check with the help of this behavior, we will check with the help of assertions. This is property idle state property, and you can write this assert idle state, assert property setup phase, or assert property access state. If this is not true, then we will get our error display, or if it is true, then there will be no display.
Here goes, I lost all feeling from my head to my toes. You said some shit that I can't let go, so just stay tuned for the rest of the show.